So vectorization is currently what we have the messages as a list of tokens, also known as lemmas. So currently we have all the messages in the form of tokens, like just words, also known as lemmas, and now we need to convert them in those messages into a vector. Now, how can we make that into a vector? And that is the big question, right? To be able to convert each message, we represent the list of tokens, lemmas above, into a vector that machine learning models can understand. So the way we're going to do that is by counting how many times does a word occur in each message, known as a term frequency. We're going to weight the counts so that the frequency tokens get lower weight. Inverse, we call that the inverse document frequency. Yeah, so that's going to be an interesting value, but we'll figure out how to do it. So that's just how we do the weight of counts. It's just going to be, we'll figure out that part. There's a specific formula we need to use. And then we're going to normalize the vectors to unit lengths to abstract from the original text length. So the way we're going to begin is we're going to take each vector. Each vector will have as many dimensions as there are unique words in the message corpus. So depending on how many unique words we actually have, that's how many vectors we're going to have. The size of your vector. We will first use the sklearn counter vectorizer. This model will convert the collection of text documents to a matrix to token count. So fortunately, we already have a tool that makes this for us. We can imagine this is a two-dimensional matrix where the one-dimensional is the entire vocabulary. One road per word. So in actual documents, in this case, column per message. So let me explain what this is doing. Let me clear this. Oh. So in the left side, we're gonna have all the words, all the unique words in our corpus. So we're gonna have all the unique words. So word 1 all the way to word n. This is how many unique words we actually have. And what we're going to be doing here is we're going to count what's the frequency of word number 1 appearing on message 1. How many times did the word 1 appear in message 2? How many times did the word 1 appears in message n? And so we're going to be doing that for every unique word that we see on the message. So we're probably going to have to take all the unique words and we're going to then look at them and it's every single message. That's practically what we're doing here. Since there are so many messages, we can expect a lot of zero counts for the representation of the word in the document. Because of this guy, sklearn will output a sparse matrix. So fortunately, we have already a tool that allows us to be able to convert this. And so what we're going to do is we're going to extract from the sklearn dot feature dot underscore extraction dot text import count vectorizer. So we're gonna import this count vectorizer from the sklearn features, and that's gonna make life a lot easier. We're gonna be able to just do this automatically without having to do it manually, right? So that's the goal, right? Fortunately, we already have that. There are a lot of arguments in the parameters that can be passed to the count vectorizer, but we just need, for us, we're just gonna need one. Okay, so what we're gonna do is we're gonna make a bowl of the transformers. So we're gonna use this count vectorizer, and the parameter that we're looking at is called the analyzer. We talked about in the lecture PowerPoint about that, and we're going to put there is how we're going to analyze this data. So the way we're going to do that is by using the process. So remember we did this manually before, so now we can just use this count vectorizer, which is going to be able to count the frequency of every word. It's going to separate the frequency and per messages. So it's probably going to be able to do this that we have done. It's going to be able to do that table that we're looking at right now. This table. And so we're gonna fit our count vectorizer with the messages, and we're gonna look specifically at the message. We're gonna print the length of our bool transformer vocabulary. Oops, I forgot to run the front. So you gotta remember, don't forget to run that line first. And right now what we're doing is we're looking at the how many vocabularies we're gonna have here. Oops, sorry. There's an underscore here. Okay. So this is telling us that there is going to be 11,425 words in our count here. And so now let's take one text message and get its back of words count as a vector, put in the use of the new bool transformer. So we're going to look at one specific message. So we're going to call it message 4 equals to messages, and message, we're going to look at the third one. So that's index 3. So that will be our fourth message. And we're going to print our message. So this is our message. You don't say so early, or you see already then say. Okay. So that's the message that we have right now. Now let's see what will be the vector representation of this word. So what we're gonna do is we're gonna implement the bool. So this is gonna be, we're gonna call bool 4, and our bool transformer dot transform the message 4. We're gonna print the bool 4. We're gonna print the bool 4 dot shape. So so this is telling us that there's a word that is appearing twice. All these other words are appearing once. So there's 7 unique words here. 1, 2, 3, 4, 5, 6, 7. So there's 7 unique words in here, and out of those 7, 2 of them appear twice. So say, and then there's also you and you that appear twice. So yep. So yeah, so that means that there's 7 unique words in the message number 4 after removing the common top words. 2 of them appear twice, the rest of only once. So let's go ahead and check the confirm which ones appear twice. All right, so let's print the bool transformer dot get features main out, and 4,608. So let's see what word is that. And let's do 9,554. So this is just to confirm that we actually get the U and the C. This is saying that the from the unique words that we have transform into a vector, right here into a vector, right? The 4,068 word appears twice in our message 4, and the word 9,554 appears twice in our message. So we're looking right now at the 4,668 word in our transformer, the one we just built, the vectorizer. And we're looking at those two words, and you can see that it's telling us that you and say are the ones that appear twice in our message. Again, we can look at the message 4 if you want to see it, right? Again. Right, you can see you and say appear twice. Okay, so now we can use the dot transform on our bag of words, the bow, to transform object and transform the entire data frame of our message. So we're gonna do that just in general. So right now we just did it for message 4, but now we're gonna do it for the entire data frame. So what we're gonna do is we're gonna call it a messages dot bow, and it's going to be equal to bow transformer dot transform messages from our message Let's see if there's no problem there. And what we're gonna do now is we're gonna print the shape. Just gonna print this right here. And I'm just gonna keep it simple, comma, and we're just gonna do a messages underscore bow dot shape. So we're gonna see what's the shape of our dimensions for our bow, and then we're gonna do the same thing here. Print and the amount, comma, and this is going to be the messages dot number of non-zeros. So what we're doing is we're looking at our message bow that we just created. We want to see how many values do we actually have. Okay, so we did this for our single message. Now we're doing it for our entire message data frame. So we had 5,572 different messages. So that's where we're getting that part, and then we're getting into the different dimension, the number of sides for our words. Now this is going to represent how many entries do we have a non-zero. So we have 50,795 that are non-zero. And so in order to look at the sparsity, how many entries do we actually have, right? How many entries do we actually have in there? So remember, this right here is creating your, let me show you guys that is this table that I showed you guys before. This table right here. This is your messages, which is like 5,000 something, something, something. And this is the number of words. How many counts of words do we have? So that's what we're counting right now. That's what I highlighted before. So that's this thing. So this is the number of messages. This is going to be your columns, and this is going to be your rows. How many words do we have? How many unique words do we have? So we want to look at the sparsity. And let me stop this one and start on the next one.